Alright, so this is 5 pi over 6 graphing the other trig functions that we haven't graphed. That'll include secant, cosecant, tangent, cotangent. Let's first look at the secant and cosecant. So secant and cosecant, when we graph it, we want to keep in mind that the secant, which is the 1 over cosine, is undefined at where cosine x is 0, and the cosecant, which is 1 over sine, is undefined where sine x is 0. So how do we graph these? Well, we first graph the sine or cosine associated with each one, and then from the hilltops, our sine or secant or cosecant forms a U going up away from the hilltops, and a U, upside down U, going down away from the valleys, and that applies to both secant and cosecant, whichever one it is, right? And our valleys and hills are just going to be shifted according to whether it's a sine or the cosine wave that's associated with that particular function. All right, so one thing we'll come back to. We'll come back to noticing the domain of each function. Okay, and just keep in mind the domain cannot include places where cosine x is 0 or sine x is 0 for cosine x for the secant and sine x for the cosecant. All right, so let's graph one period of y equals negative 2 secant of the quantity 2x minus pi over 2, close quantity, and then plus 1. So the first thing is to note what the secant is related to. Well, it's related to the cosine. So we're going to really graph y equals negative 2 cosine of the quantity 2x minus pi over 2 plus 1. All right, so if I factor out from the 2x minus pi over 2, I'm going to factor out the 2 just so I can see my phase shift. And that's if I factor out the 2, it's 2 times the quantity x minus pi over 4. So my phase shift is pi over 4, which means it'll be shifted pi over 4 to the right. All right, and I'm going to do my 0 is less than or equal to 2x minus pi over 2, less than or equal to 2 pi. So I'm going to add pi over 2. So this will be pi over 2 is less than or equal to 2x, less than or equal to, this is 4 pi over 2 plus pi over 2 is 5 pi over 2. And then to solve for x, I'm going to take half of every quantity. So it's pi over 4 less than or equal to x, less than or equal to 5 pi over 4. Again, notice because of the 2 in the argument, our period is cut in half. Okay, it means that instead of going from 0 to 2 pi or a period of 2 pi, it's a period of pi. Okay, so from pi over 4 to negative, from pi over 4 to 5 pi over 4. All right, so I'm going to, my units are in pi over 2, so I'm going to split it at pi over 4, and I'm going to draw my my vertical lines there. Remember my vertical lines where I delineate a tile? 5 pi over 4 is a pi over 4 past the pi. Okay, and then I'm also going to put a dotted line where it got shifted up. So it got shifted up 1, so I'm going to put a up 1. So I'm going to put a dotted line at y equals positive 1. And remember, the reason why I do that is because my sine and cosine both, some of them are above the x-axis, some below, right? Part of it up above, part of it below. So this will function as my x-axis. Okay, so y equals 1 will function as my x-axis when it's shifted up. All right, so I'm going to graph negative 2 times the cosine. So I'm going to mark off the halfway point, which is 3 pi over 4. And then quarter points, which will be 2 pi over 4, which is pi over 2, and pi. Okay, and I'm graphing the cosine. Remember, the cosine starts at 0, 1, but double will start at 0, 2. I'm sorry, not at 0, 2, but 2 up from where my left part of my tile begins. But because it's a negative 2, it's upside down, so it'll start at the bottom, and this is actually the point pi over 4, negative 1. Right, because it got shifted up by 1, so it's not at pi over 4 negative 2, it's pi over 4 negative 1. That'll be a key point, but it's for the cosine, so not for the secant. All right, then it goes up, and at the quarter mark, it crosses the x-axis, but this time it's the line y equals 1. And then it goes up at the halfway point, it's 2 up, comes back down to y equals 1, and then comes back down to negative 2 at the last section of it, right? So it starts off, and at the quarter point, it's going to cross the line y equals 1. At the halfway point, it's at y equals 3. At the 3/4 away, it's at y equals 1 again. And at its full cycle, it's at y equals -2. Okay, so that's my cosine that's associated with this particular secant. And I'm going to include the rest of the curve, and this is just so that I'll see where is my, and I can put this as dotted line, dotted curve, right? Where's the rest of my curve going? All right, and I'm only going to put a, just for me, your book does it, includes, the whole U and all of that. I'm going to say that my U, or upside down U, extends from the bottom of the valley. Okay, so right, and then it has asymptotes at the x-intercepts, which correspond to the halfway point and the endpoints. Okay, so there's part of my graph, and it really continues all the way to make the U. Okay, upside down U or U, whichever one applies. All right. And these dotted lines that I'm putting on the U's, you can put them as solid lines because the U's are there. Yeah, and we're not graphing just one period of the secant or cosecant. Notice we're not asked to do that, so we can graph as many periods as we want. And of course, once you establish one period, the rest of them are tiled to the left and to the right and complete the full graph. Okay, so there's my graph of y equals -2 secant of 2x, quantity 2x minus pi over 2 plus 1. Okay, notice we also don't have key points for this one, other than maybe we can consider key points the places where they coincide with the sine or cosine associated with them. Like in this case, we have a point that we know at pi over 4 -1, at 3 pi over 4 positive 3, and at 5 pi over 4 -1. Okay, and those are just the places where the U's, the tail end or the bottom or top of the U's, upside down U's, or bottom of the right side up U's, touch the associated sine or cosine wave. Okay, so there's my sketch of that. All right, let's do a couple more here. All right, so we are also going to look at the graph of tangent and cotangent. And so what we want to notice about the tangent is it has a period of pi. I don't know if you guys remember, we talked about this before. And the tangent in particular is undefined, where cosine is 0, which is at, if we look at the regular sine and cosine, just from 0 to 2 pi, without any shifting, negative pi over 2 and pi over 2, or odd multiples of pi over 2, is where the tangent will be undefined. So one period we can think of as going from negative pi over 2 to pi over 2. And I would say stick to that, okay? And then worry about shifting. Okay, so one period from negative pi over 2 to pi over 2. Okay, that's a length of pi. All right, the cotangent, so we do have some key points. So we consider that. I'm sorry, I was going to skip this. We do have 0, 0 as a key point. That means the x-intercept is at 0 or halfway through its period. And then negative pi over 4 -1, and also pi over 4 +1. Those are nice key points to remember. And if your period changes, just keep in mind that negative pi over 4 is halfway from 0 to negative pi over 2. And that pi over 4 is halfway from 0 to pi over 2. Right? So at the quarter marks, the tangent will go down to -1 and up to +1. And at the halfway mark, it's at the x-intercept. All right, the cotangent just turns upside down. Is the tangent upside down? Because it's cosine over sine, then it's undefined where the sine is 0, and that changes from 0 to pi and negative pi and 2 pi. That means multiples of pi. So in multiples of pi, it has vertical asymptotes, just like the tangent had vertical asymptotes at at odd multiples of pi over 2. All right, so this one, we're going to think of a period because it has vertical asymptotes at multiples of pi. We'll think of a period as from 0 to pi. Okay, and from 0 to pi, it's an upside down tangent curve, so it drops. It's a decreasing curve. It does have an x-intercept halfway through, so at pi over 2, and then key points pi over 4, 1, and 3 pi over 4, negative 1. Right? So notice it's really the same as the tangent, right? Just except upside down. All right, so let's graph one of these. So let's graph y equals negative 2 cotangent pi over 4 x. So pi over 4x, so my period is going to be divided by pi over 4. Yeah? So 2 pi divided by pi over 4, that's like 2 pi times 4 over pi. So 2 times 4 is 8. So the period is 8. Uh-oh, goes from 0 to 8 instead of from 0 to pi. Yeah? Okay, so I'll have to adjust my axes here because I have from negative 5 to 5 on the x-axis. Okay, so this will be, let me write it down, 2 pi times 4 over pi, and that'll be 8. All right, and the negative 2 is going to flip it upside down, so it's going to make it look like a tangent and double the vertical distance. So instead of having a key point at a quarter of the way and 1 up, it'll be a quarter of the way and 1 down, because the cotangent had a quarter of the way and 1 up. So negative 2 times the cotangent, I'm sorry, a quarter of the way and 2 down from the x-intercept. Okay, so the x-intercept is going to be half the way from 0 to 8. So it'll be at 4, will be an x-intercept. All right, vertical asymptote at x equals 0. And at x equals 8, so I need to add numbers here, 5, 6, 7, 8. All right, so it'll be a vertical asymptote there. All right, so I have an x-intercept at 4, 0, and then at 2, which is a quarter of the way up, and 2 down, there's a key point, and then the other quarter of the way, which will be at 6, and then it'll be 2 up. That'll be a key point. All right, so I'm going to fill in my curve. And there's my curve there for the cotangent. Y equals negative 2 cotangent pi over 4x. All right, and we'll leave the second example for class. Let's do one more. All right, so letter C says write a function of the form y equals a secant bx minus c plus d, y equals a cosecant of the quantity bx minus c